On the morning of September 30th, 1999, 3 technicians at a Japanese nuclear fuel processing facility were manually pouring liquid uranium into a vat. To speed up their work, they bypassed the facility's mechanical pumps and mixed the highly enriched solution by hand using ordinary stainless steel buckets. At exactly 10:35 a.m., the room was violently illuminated by a blinding blue flash of Cherenkov radiation. Instantly, gamma alarms began blaring across the facility. The liquid inside the tank had achieved critical mass. An uncontrolled nuclear chain reaction was now firing continuously. Within seconds, the 3 men experienced overwhelming pain, severe nausea, and difficulty breathing, forcing them to evacuate the room. This was the start of the 1999 Tokaimura nuclear accident, at the time, the worst civilian nuclear radiation disaster in Japanese history. In that split second, the blue light transformed a mundane industrial task into a lethal collision with the laws of physics. To understand how those workers ended up holding buckets of liquid uranium, we have to look at where this happened. The village of Tokai sits on the coast of Ibaraki Prefecture, about 70 miles northeast of Tokyo. Japan is a nation with few natural energy resources, and it relies heavily on imports. To gain energy independence, the government built a massive network of research centers, fuel fabrication plants, and commercial reactors right here in Tokai. Nearly 1/3 of the local population relied on the nuclear industry for their livelihoods. 2 years prior to the blue flash, the town experienced its first serious warning sign. On March 11, 1997, a completely different facility in Tokai was experimenting with a low-level radioactive waste mixture. The asphalt caught fire, and hours later, built-up flammable gases exploded. The blast shattered doors and windows, allowing radiation and smoke to escape the building. 37 facility personnel were exposed to trace amounts of radiation. Instead of cooperating with safety authorities, facility management ordered 2 workers to falsely report the chronology of events. They actively delayed reporting the fire to the government in order to cover up their own lack of supervision. The successful suppression of this timeline proved that the national regulatory system was blind to what actually happened inside these plants. Deliberate safety violations could be successfully hidden, establishing a precedent that would prove fatal in 1999. By the fall of 1999, the Japan Nuclear Fuel Conversion Company, known as JCO, was facing steep financial pressure. Revenue was down, layoffs were common, and the company needed to process a batch of fuel they hadn't made in 3 years. The technicians assigned to the floor lacked any specific training for this particular chemical process. The legally required procedure for enriching this fuel was precise. Workers were supposed to dissolve uranium oxide powder, convert it to aqueous uranyl nitrate, and then slowly pump that liquid through a tall, narrow buffer tank. The tank's geometry was specifically engineered to keep the uranium molecules spread out, preventing them from grouping together and reacting. But the JCO technicians completely bypassed the buffer tank. Instead, they carried the liquid by hand in stainless steel buckets and poured it directly into a wide, squat cylindrical precipitation tank. JCO had actually codified this shortcut in an unauthorized 1996 operating manual. By recommending buckets instead of the specialized pump system, the company could shave hours off their processing time. Management had approved these hazardous shortcuts as far back as 1993. The financial demand for efficiency was institutionalized into the company's internal documents, turning a severe regulatory violation into a mandatory daily routine. That brings us back to 10:35 a.m. The technicians had already dumped 6 buckets of uranyl nitrate into the wide tank. When they poured in the 7th bucket, the tank's fill level reached 16 kilograms of uranium, almost 7 times the legal mass limit. Because they used the wide cylindrical tank instead of the narrow buffer tank, the massive quantity of uranium was able to pool together into a critical mass. The self-sustaining chain reaction of nuclear fission began instantly. There was no criticality alarm installed in the building. Furthermore, the site wasn't even included in the National Plan for the Prevention of Nuclear Disasters. The licensing board had explicitly concluded that a criticality accident simply could not happen at this facility. Because no emergency plan existed, the local response was paralyzed. It took 5 hours to begin evacuating the 161 people living immediately around the plant. It took 12 hours to issue a shelter-in-place order for the 300,000 residents in the surrounding area. Inside the plant, the fission reaction continued to burn. The following morning, workers stopped the chain reaction by draining water from the tank's cooling jacket, which had been acting as a neutron reflector, and pumping in a neutron-absorbing boric acid solution. An entire regulatory apparatus had been engineered around the assumption that an accident of this magnitude was impossible. When physics proved that assumption false, the system was entirely helpless to stop it. The legal limit for radiation exposure for Japanese nuclear workers is 50 millisieverts per year. The 3 technicians leaning over the tank absorbed massive doses in seconds. Yutaka Yokokawa, the supervisor sitting at a desk nearby, absorbed 3 sieverts. Masato Shinohara absorbed 10. Hisashi Auchi, who was draped directly over the tank while pouring, absorbed 17 sieverts. Auchi was transported to the University of Tokyo Hospital, where he survived for 83 days. The radiation completely shattered his chromosomes, leaving them entirely unidentifiable under a microscope. His white blood cell count dropped to near 0, systematically dismantling his immune system. Doctors attempted a peripheral blood stem cell transplant, a highly experimental treatment at the time, along with extensive skin grafts and pharmacological interventions. But his body continued to deteriorate, resulting in multiple organ failure. Ochi passed away on December 21, 1999. His colleague Masato Shinohara died of lung and kidney failure 4 months later. At this level of cellular destruction, modern medical intervention is powerless. The broad, abstract failures of corporate management ultimately narrow down to a deeply intimate, inescapable physical toll. The damage extended well past the walls of the processing room. At least 667 people, including plant workers, first responders, and local residents, were exposed to excess radiation as a direct result of the event. The Japanese government stripped JACO of its operating credentials, marking the first time a Japanese plant operator was legally punished for mishandling nuclear radiation. The company agreed to pay $121 million to settle thousands of compensation claims, and 6 JACO officials ultimately pleaded guilty to professional negligence. In response to the disaster, Japan implemented new special laws mandating strict operational safety procedures, regular quarterly inspections, and comprehensive safety education for all workers handling nuclear materials. The trauma of Tokaimura fueled a surge in anti-nuclear activism across the country. It highlighted the tension between Japan's need for domestic power generation and the safety of its citizens, a tension that would erupt on an even larger scale a decade later in Fukushima. The 7th bucket represents a catastrophic breakdown of human management rather than a failure of technology. It is a reminder that in the atomic age, the most advanced systems remain vulnerable to the simplest forms of complacency.